So as we wrap up Chapter 2, Lesson 1, we have to talk about the term biconditional. Okay, this is what we would do if we have a true conditional, and then we look at the converse, and the converse is also true. They're both very useful rules, but we don't have to use both of them all the time. It's a lot of writing, or it's a lot of looking at two different statements. So we try to combine them. So it's going to, instead of using if and then, it's going to use the phrase if and only if in the middle. And there's a lot of times where we actually will just, instead of saying if and only if, we use IFF to stand for that. And if you look at the symbolism here, we've looked at P with an arrow to Q, and then with the converse, we kind of flip the P and the Q around. If it's a biconditional, we still will use P and Q, but now you see we have a double arrow there. That means that the statement can go both ways. Okay, so we'll just look at a quick example, and then we'll try to practice a little bit. If we had an original conditional, if an angle is right, or if an angle is a right angle, then it has a measure of 90 degrees. I think we would agree with that statement. And if we look at the converse, if an angle has a measure of 90 degrees, then it is a right angle. That's basically what a converse is, but I think we agree that both of them are true. So the biconditional says take the original hypothesis part and the original conclusion part. I lost my train of thought there. And instead of having if and then in front of them, you just put if and only if in the middle. So the biconditional would be an angle is right if and only if it has a measure of 90 degrees. And all of a sudden, that's a definition. So we generally will put the term first, and then if and only if, and then the characteristics, which is what we've done here. The term is a right angle, characteristics, measure of 90 degrees. Okay, so we're going to look at statements like this and combine them into one, and then we'll also kind of go the other way and say, well, if we have that biconditional, can we break it apart into the two original conditional statements? But this is going to be really important down the road, because a lot of what we're going to do, it's going to have a little logical aspect to it. We have to be able to explain why we know something. In a biconditional statement, it's going to be a little bit more useful than the original conditional. So you have to trust me on that a little bit for now. But these are good building blocks for us to be looking at. Okay, so if we look at another statement, if the original conditional, if array is an angle bisector, then it will divide an angle into two congruent angles. That one's a little bit more complicated, because you do need to remember what an angle bisector is, but just remember that array is going to go right down the middle of a big angle, and it does create two congruent, or two angles that have the same measure. If we looked at the converse, okay, if array divides an angle into two congruent angles, then it is an angle bisector. Kind of saying the same thing, but in the reverse order. So you're saying we're looking at a picture, we notice that two congruent angles have been formed. That means that array split it in half, therefore it's an angle bisector. Okay, well, both of those are true, and you can kind of see the idea of a term, angle bisector, and then the characteristics, it divides. We can write that as a biconditional. Okay, so this is what I would do. And if you need to pause this at some point just to jot it down, go for it. But we put the term first. Array is an angle bisector. Angle bisector is that term, and we know it's got to be array. So an array is an angle bisector if and only if it divides an angle into two congruent angles. Okay, then we also want to be able to go in the opposite direction. So if I gave you this statement here, two numbers are reciprocals if and only if their product is 1, could we go backwards and write the two original statements that this came from? So first of all, just remember what reciprocals are. If we started off with 2/3, 3/2 would be the reciprocal. If we had 5/9, 9/5 would be the reciprocal. So if you think about that, if you took 2/3 and 3/2 and you multiply them together, you multiply the numerators together, you multiply the denominators together. For that example, you'd get 6/6. If you had 5/9 and 9/5, you'd get 45/45. Go through a few more examples, it's going to work the same way. Okay, so that's what a reciprocal is. So we need to think about how we would break it apart into two if and then statements. So if you can find the if and only if part, basically that's the cutoff there. The first part could be your if part, and the second part could be the then part, which is what I did here. If two numbers are reciprocals, then their product is 1. That's the easy one. Okay, when you find the other conditional, you have to still need to think about an English class. Like the subject should have a little bit more of the details. So I don't want to say if their product is one, then two numbers are reciprocals. I don't want that pronoun of their to come first. Okay, so we want the idea of two numbers to still be first. So if the product of two numbers is one, then they are reciprocals. Okay, so let's make sure that we have the main details in that first part. So this can be a little confusing when it comes down to writing things out. We'll practice that a bit. But a biconditional is going to be more useful than an individual conditional or two.